This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and please participate, but please do not share personal information during the class session. Thank you so much. All right, guys, at this point, you should have your attendance ticket open. I see a lot of green checks telling me you guys have it open, but in the chat box, click that link, scroll down, enter the password that you see in the chat box. Make sure you use a capital letter Q for that first letter. And then what am I saying? What am I saying? And then click Start Quiz to open up that attendance ticket. Don't do anything with it yet. I will be giving you the answers as we go through class. Again, password is only in the live class. Okay, Michael, if you're ever having issues with the attendance ticket, just remember to take a picture of the screen. That way you have it saved for once it does start finally working. Okay, perfect. Awesome. You are so on top of it. Love it. Okay, Annalise, you can either play in a browser, so you can just open up a browser on Google Chrome or Firefox or Internet Explorer, or you can also play in the chat box, but it is more fun if you get to play in a browser so that you can get points. Yeah, all right, so today, guys, we do have our Unit 4 game day. We went through Unit 4 so quickly. I hope you guys enjoyed it because it was a super short one. Tomorrow, we will be going over Unit 5. We're going to start Unit 5. That's going to go all the way into next week as well. So fluid forces, that was what we talked about this unit. We talked about forces, pressure for fluids. We talked about density, how objects move through fluids, and we talked about Pascal's and Bernoulli's principles. Yeah, that's a good question, actually. Annalise, how did you break your phone? You just dropped it in some bleach? All right, guys. So just really quick overview of where we've been. Remember, day one of of unit one, we talked about pressure. And remember, pressure is just another word for molecules colliding. So pressure is due to the collisions of molecules. More collisions, more pressure, right? Smiley faces, if you remember that, more collisions, more pressure. And again, we can get more collisions in a few different ways, right? From increasing the temperature, because those molecules run around faster, and when you're sprinting around, you're going to increase the collisions. Smaller volumes, right? If you try to get all those molecules stuffed into a really tiny space, they have no place to move, so wherever they move, they're going to be colliding. So that's definitely a lot more pressure. And if you add more molecules, like when we fill up a car tire, we add air to that car tire. We're adding more molecules. More molecules means more collisions, more pressure. Okay? So this is number one in your attendance ticket. Please give me a green check when you have this saved. We're going to blow through these and then we're going to start our game. So make sure you are on top of it. 20 seconds more. Go, everyone. Go, go, go. Looking good. All right. Andres, Andrew, Anthony, Audrey, make sure I get your green checks, please. Dalen, Dolly, let's see here. Haley, I know you just joined us. Open that up and get your first question filled out. Jake, Jeremy, Olivia, or sorry, Vega. Oh, Vega, good to see you. I feel like I haven't seen you in a while. Zoe O, make sure I get all your green checks, please. Oh, yeah, definitely, Libby. Always good practice. All right, perfect. Oh, totally, Michael. So as soon as you take a picture, just give me a green check saying that you've taken the picture. Love it. Looking good, guys. All right, so on Monday, we also talked about buoyancy. That was our second concept on Monday. And remember, buoyancy is just the upward force that's a result of the relationship between an object's density and a fluid's density. So remember, we learned that if the object is less dense than the fluid, it floats. If it's more dense, it sinks. And if it's the same density, it's going to stay suspended in the middle. So again, we learned about things like ice. Does ice have more, less, or the same density as water? Does ice have more, less, or the same density as water? What do you guys think? Again, if it floats, it floats. So what's its density going to be like? What is ice's density going to be like? Yeah, exactly. It's going to be less dense, right? Less dense, it's going to float. Awesome. This is number two. Give me a green check when you have that saved. You guys have 30 seconds. Again, we're flying through these so that we can get to our game. Love it. Work quickly, everyone. Perfect. Seja, if you get a chance, can you stay after class really quickly? You're not in trouble or anything. I just need to talk to you really fast. Thank you. All right, perfect. All right, looking good, looking good. All right, guys, the next one that we talked about yesterday, remember, was Pascal's principle. And Pascal's principle said that if you apply pressure at one point to an enclosed fluid, then all points feel the same increase in pressure, right? We talked about this. When you squeeze a water bottle, it's not like just one part of the water bottle gets harder. It's the entire water bottle gets hard because the entire water bottle at every point is feeling more pressure. Smiley faces if that makes sense, right? Every part of it is feeling more pressure. And this actually helps us with hydraulic machines to lift heavy objects. Remember, with a hydraulic machine, we don't need to put in a lot of force. You can see right here, this person is just putting in a little bit of force on this one point in the fluid. But what happens is that on the other side, because every point is feeling the same amount of pressure, all those little forces add up to be able to pick up a gigantic car. Okay, remember that? Give me a smiley face if you remember this. That because all of these points feel the same amount of pressure, those forces multiply. Shh, shh, shh. Those forces multiply and we end up being able to pick up a car. Pretty crazy way that hydraulic machines work. I don't know. That's a good question, Adrian. I guess uniform just because it just means like all over pretty much the same. But saying all over pretty much the same is just not as succinct or as easy as saying uniform. All right, go ahead and answer question number 3. Give me a green check when you have that saved. It's a short word, so you guys have 20 seconds. Go. Perfect. Green checks from Andres, Audrey, Libby, Haley, Jake, Jeremy, Johnny, Sophia, Ty, and Zoe O. Make sure I get your green checks. Awesome, you guys are on it. And then the last thing that we talked about yesterday is why airplanes are able to fly, right? We talked about Bernoulli's principle. And we said that when we increase velocity, that results in lower pressure, right? Because those molecules, when they're increasing velocity, they get spread out, which means they can't collide as much. So less collisions, less pressure. And we saw that when we were taking pictures. I'm reading the chat box and trying to talk at the same time. We talked about this when I did that demo of the levitating paper, right? I blew on top of that strip of paper and the paper suddenly lifted. And the reason for that is because on top there was less pressure. On the bottom there was more pressure because those molecules on the bottom weren't moving. They were close together. They were colliding, which meant high pressure. So when there's low pressure on top, high pressure below, all of that pushes up. And so a wing is able to lift, right? That's the word for a wing going up. It's called lift, that upward force. Smiley faces if we felt good about this yesterday. Smiley faces if all of that made sense. Awesome, looking good. This is number 4, green checks when you have this one saved. All right, and we're going to start our game soon. You guys have 20 seconds. Green checks, everyone. Perfect, Angelina, Annalise, Anthony, make sure I get your green checks. Dalen, Haley, Jake, Johnny, make sure I get your green checks, everyone. What kind of soup, Kim? Looking good, guys. All right, so here's what's going to happen. Oh, I love ramen. We know the drill, guys. You're going to go to kahoot.it. Okay, you can either do this in a phone browser, you can do this on a computer browser, so just open up a new window on your computer. You can do this in the app. Your phone can also do the Kahoot app if you already have that downloaded. All right, so what we're going to do, you're going to open that up. You're going to go ahead and enter the game pin. I will give that to you in a moment. Just be patient. But a reminder that once you enter your game pin, it's going to ask for your name. I need you, again, to enter your real name so that I can give you points. Okay, so you need to enter your first name with your last initial. Do not put your entire last name because, again, this is being recorded. All right, so again, do not put your entire last name, just your last initial. And remember, any inappropriate names, you'll be removed and you'll get disciplinary action. So just don't be silly, right? Make sure you guys are doing this correctly. Yes, Dolly, give me a second. All right, I opened it up for you. If you guys are having any issues, like Dolly, with opening up the Kahoot game, let me know and I can open a private chat for you so that you can answer in the chat. You just unfortunately won't be able to be in the competition, but that's okay. So if you're having any issues, let me know. I do want you to still get your extra credit. So you can still get your extra credit. that way. All right, remember, do your best, okay? You'll get extra credit as long as you participate. And if you are watching the recording, unfortunately, you will not be able to get extra credit because this is a game. And so the only way you can do this is if you're out in the live session, and there are no exceptions, even for things like work and doctor's appointments, unfortunately. All right, give me a thumbs up if we are ready to play. I'm going to go ahead and get this started and get you your pin in a moment. Looking good, looking good. Love the enthusiasm. All right, I'm sharing this with you on the whiteboard. Okay, sorry, I'm almost sharing this with you on the whiteboard so that I can see the chat box still. Perfect. Okay, so here we go. I'm going to go ahead and make sure this is all correct. Looking good. All right, here we go. Oh no, Kim. You worked so hard for that soup as well. All right, enter that pin. I should see you start popping up on here. Love it. Again, first name, last initial. No full last names, please. Only the last initial. Oh no, Libby. Actually, my daughter dropped my phone from on top of the changing table, and so now it's broken, and I'm going to get a new phone today. So that's going to happen after I do tutoring. Phones are definitely having some issues this week, right? All right, looking good. I have 23 players so far. There's 34 of you in the room, so I should get about 30 or more of you up here. Make sure you're paying attention. Make sure you're participating. Again, if you're just in class not doing anything, you will not get extra credit. Ooh, a little snake. How'd you do that? That's pretty cool. Keep going, guys. Get your answers up there. Get your names up there. Sorry, not answers. Get your names up there. You love snakes. Snakes are pretty cool, as long as they're not the kind that can hurt you, right? Looking good. I'll give you guys about 10 more seconds. You can always join later. Just remember, you might not get as much extra credit if you join super late. So try to join now so that you can get all your extra credit. Okay, awesome, Haley. Glad you're working on it. Oh, what are you getting on the 30th? That's exciting. Awesome, Haley. I see you on the board. Zoe, what are you getting? That's exciting. All right, awesome, Jacob. As long as you tell me, Adrian, in the private chat what it is, I'm totally fine with that. All right, a leopard gecko. Oh, cool. Albino. Oh man, that's so exciting. Ball pythons are pretty neat. All right, let's go ahead and get started. All right, awesome. All right, let's go ahead and keep on going. All right, here we go. Are you ready to rumble? All right, another way to think about pressure is as what? What is another way to think about pressure? No, Adrian, you're ready to win. At least win some extra credit. Awesome, thank you, Siva. Dolly, make sure I get your answer. Oh, I saw yours. Good, awesome, thank you. I know, Avatar is pretty awesome. I heard on Facebook that they are going to have Avatar live action coming out soon, and I've currently been watching that new show. What's the show called on Netflix? I totally just forgot the name of it. With the moon elves by the same people. No. It literally just got released on Netflix. I'm having such a brain fart right now. Oh yeah, the Dragon Prince. There you go. Thank you, Edgar. I know, super exciting. All right, looking good. Yes, pressure is collisions. Remember, more collisions, more pressure. More collisions, more pressure. All right, Anthony in the lead. Let's make sure that this makes sense. I just want to show this to you really quickly. Right, so pressure is caused by collisions against the surface. Those collisions push against the container. They increase pressure. Let me know if that makes sense. Let me know if that makes sense. Answer on your phone. Pressure is collisions. Collisions of molecules. 10 seconds. This way we can review as we do the game instead of having to wait to review afterwards. Looking good. Awesome. Okay, good. Glad it's starting to make sense. Awesome. All right, if temperature is increased, giving molecules more energy, then those molecules will have what? Less collisions, less pressure. More collisions, less pressure. More collisions, more pressure. Less collisions, more pressure. All right, remember, what's the relationship between collisions and pressure? And what's temperature going to do to the collisions? Awesome, get your answers up there. Remember, we're just doing our best, so even if you have to guess and you're not sure, still put an answer so you get your extra credit. Awesome. Thank you, Siva. Dolly, make sure I get your answer too. Yeah, I know. Sometimes those shows aren't everyone's jam. Oh, my husband just finished watching the latest season of that. Awesome. Thank you, Dolly. Looking good. 7 seconds left. Get your answer up there quickly. Just do your best. Yes, you guys are correct. More collisions, more pressure, right? If you have more energy, with more energy, those molecules are sprinting around, and sprinting around means more collisions, and collisions just means pressure. Awesome. Grant is in the lead. So let's make sure that this makes sense. Let's make sure that this makes sense. Again, increased temperature, more collisions, more pressure, right? With more temperature, they have more energy to collide. The hotter molecules get, the more they're moving, the more energy they have to collide. Awesome. Hi, Emilio. Go ahead, join our game. Go to kahoot.it. The pin is down here, 427-0565. Get your extra credit. Love it. Awesome, Siva. Looking good. Awesome. Glad that's making sense. Good. All right. Let's keep going. If volume is increased, they have more space, then what's going to happen to those collisions and pressure? Again, they have more space to move around. More space to move around. Get your answers up there. What? Yeah. Oh no, Kim. No worries. Just do your best. Right? Just remember you'll be able to get that extra credit. It's all good. Done goofed. It's okay. Awesome. Thank you, Siva. I know this is a hard question, isn't it? Are you telling the students it's okay? Awesome. Thank you, Dolly. 20 seconds left. Dun, dun, dun. Yes. 10 seconds. Yeah, you guys are doing awesome. As long as you're putting in the effort and you're learning, that's what matters. Yes, less collisions, so less pressure. All right, let's make sure that this makes sense. Do you want down? Is that what it is? Right? With more volume, they have more space to move around, so they're not going to collide as much, right? If you give more space to them, they won't collide as much, which means less pressure. All right, let me know if that makes sense. Awesome. Thank you, Dolly. Thank you, Siva. What? All right. Get your answers in there. This is a fast one. Perfect. Okay. All right. So we can go over that again if we need to. All right. But again, let's talk about that. So if we give 100 people a gigantic space like a castle, are they going to run into each other more or less, guys? If we give them a gigantic amount of space, are you going to run into them more or less? Yeah, so you're going to have less collisions. The bigger the space, the less collisions, and therefore less pressure. Okay, smiley faces if that makes more sense. Smiley faces if that makes more sense. Awesome, looking good. All right, let's keep on going. Grant in the lead, Edgar on a streak, love it. What is the equation for pressure? Equation for pressure. Yeah, it's APA. I couldn't actually find a picture that really went well with talking about equations, but I figured he's cute, so. Oh no, Ariana. There we go, get your answers up there. Awesome, thank you, Dolly. Thank you, Siva. Almost there, 10 seconds left. I know this one I didn't review explicitly in class. This one requires us to think back the couple days. Oh no. Isn't that the worst, Ariana? There we go. All right, guys, it's force divided by area. Remember, another way to say it is force per area, right? Division and per are synonyms. Okay, smiley faces, if we remember that. All right, I'm going to go ahead and show this to you on the whiteboard. Again, pressure equals force divided by area, force per area. Force per area. Awesome. Looking good, looking good. Awesome. Thank you, Dolly and Siva. All right, good. Glad that's making sense. Love it. All right, here we go. We've got a few of us on the leaderboard. If the same force is applied to two objects, the object with less area, like a high heel, okay, think about this, high heel, is that going to have the same pressure, less pressure, no pressure, or more pressure? Think about a high heel stepping on your foot. It's going to have the same pressure, less pressure, no pressure, or more pressure. All right, we'll go step on someone's foot then, Livy. I'm kidding. Don't go step on someone's foot. Awesome. Thank you, Siva. Yes, everyone's in first because everyone gets extra credit, right? Hey, Steven, join our game quickly. Kahoot.it, enter the PIN 4270565. It's okay. You can still get extra credit. Just jump on in. I don't think you'll be getting first place today, though. But you can still get your extra credit. No, Libby, don't do that. Yes, it would have more pressure, right? The smaller the area, that means all that force is being concentrated on a tiny spot, and so it's going to have way more pressure and hurt a whole lot more. Awesome. Okay, so let's make sure that that makes sense, right? So we had this picture of a high heel versus a sneaker, right? Small area, big pressure. Whereas a big area like a sneaker, it gets all spread out and it has a small pressure, right? We talked about it. If we spread out all our weight over many eggs, it's going to be less pressure, and so we're not going to break the eggs. Awesome, looking good. Oh, Libby's catching up to you, Adrian. Looking good. Awesome, guys. Love it. Glad that's making sense. All right, here we go. Still the same leaderboard currently. Why does a baseball seem heavier than a tennis ball if they're both the same size? Why does a baseball seem heavier than a tennis ball if they're the same size? Awesome. Hi, Amani. Go ahead, join our game so you can get extra credit today. Go to kahoot.it, enter our PIN 4270565. Don't cry. You guys are doing so well. It's going to be okay, guys. It's going to be okay. Yes, it's because it's more dense. All right, remember we talked about this. All right, so let's make sure that this makes sense. All right, that a tennis ball and a baseball, they're the same size, so they have the same volume, but because a baseball is able to stuff more mass into that volume, it's denser and therefore it feels heavier, right? The more you stuff into a space, the heavier it's going to feel because it's more dense. Yeah, awesome. Let's make sure that makes sense. 5 seconds left, guys. Let me know how you're feeling about that. I know this can be a tough concept. All right, good. Again, they're the same size, but the more you try to stuff into them, the more dense they are, and therefore the heavier it feels. All right? All right. Oh, looks like, Adrian, where'd you go? All right, let's get it back. If an object has the same density as water, it will what? Same density. Oh no, Adrian. Okay. All right. I believe in you, though. You can overcome the lag. Yeah. Looking good. Love it, Kim. Same density as water. It will what? Float, be suspended, or sink? What do you guys think? 30 seconds. Let's go. Let's go. I know. That's so exciting, right? Oh, no. What happened, Steve? 7 seconds left. Let's go. We got this. All right, it's going to actually be suspended, right? If it's the same density, it's going to be suspended in the middle of water. It only floats if it has less density. It only sinks if it has more density. All right, let's go ahead. This one we should all get now because I literally just told you the answer. Object has less density than water. What's it going to do? Less density, what's it going to do? There we go. Awesome, Dolly. I see your answer in the chat box. Thank you. I see yours, Siva, as well. It's left. Let's go, let's go, let's go. Awesome, Adrian. Love the confidence. Who isn't answering? I know someone's not answering because it would go straight to our answers and we wouldn't have to wait the entire time. Come on, guys. Get your answers up there. 4, 3, 2, 1. Let's go. Yes, it's going to float, right? Less density means it doesn't have as much weight for its volume, and so it's going to float, right? Awesome, Grant. Still holding on to the lead. Let's make sure this makes sense, right? We showed this diagram, right? Floats if it's less dense, suspends if it's the same density, sinks if it's more dense. All right, let me know how that feels. Livy is hunting you guys down one by one. Love it. Here we go. 6 seconds. Looking good. All right. Glad that's making sense. Awesome. All right. Since ice's density is 0.97 grams per milliliter, how much of it sinks below the surface of water? All right, this one's a hard one. Oh, you guys seem confident though. All right, love it. Love the confidence. There we go. Again, if you're not sure, just guess. Just guess. Okay, gotcha, Dolly. Looking good. Are you cheering them on? Yeah, I know. You believe in them, right? They can do it. All right. Few seconds left. Let's go. Let's go. Just do your best, Angelina. Remember, it's going to be the same percentage, right? So if the density is 0.97, the same percentage is what sinks. All right, let's make sure that makes sense. I got Grant, Vega, Libby. Let's go. Let's make sure this makes sense. All right, density, whatever the density is, that's how much sinks, right? So if our density was 0.75, then 75% would sink. All right, get your answers up there. Let's make sure that makes sense. Whatever the density of the object is in water, that's the amount that sinks. There we go. All right. I know that can kind of be a hard one to think about. Just remember, guys, if the numbers, whatever the number is, that's the same percentage. So since the number was 0.97, then 97% sinks. Okay, smiley faces if that makes a little bit more sense. Okay, just want to make sure that's making sense. All right, let's keep on going. If you increase pressure at one point of a confined fluid, this increases pressure where? Only at that one point, only at the bottom, at all points, or only at the top? What do we think, right? Remember squeezing the bottle. What happens when we squeeze the bottle? I know, this is another one that I didn't have a good picture for, so I just figured Momo would be cute. Yeah, Momo and Appa were pretty awesome, right? All right, get your answers up there. Let's go. We've got a few minutes left. Gonna try to get it through as many more questions as we can in 2 minutes. We got 2 minutes left. Let's work fast. I know, he would be a tasty snack for a snake, wouldn't he? Good thing he's fictional. You guys are awesome. Keep working, keep working. Yes, at all points of the fluid, right? We saw this in our picture here. Let's go ahead and show this. That when we squeeze the bottle, every part of the bottle feels it. All points feel it. Okay? It's not just the top that gets hard. It's not just the bottom that gets hard. Every single part gets harder from the increase in pressure. Looking good. Well, Ariana must be working hard. That's what's happening. Looking good. Awesome. Okay. Oh, Vega is on a streak. I love it. Bernoulli's principle states that increasing the speed of air will what? Increasing speed of air will what? This is our last question, guys. Do your best. This is our last question. We're going to have to skip the rest of them because we're out of time. I know. My daughter's cheering you on. She says you guys can do it. Yeah, I know. She's blowing bubbles at you. Oh, just do your best. Remember, we increase speed of air, those molecules spread out. What happens as those molecules spread out? You got this. I know, it's so exciting. It's the end of the game. Yeah, yeah. No, Steve, what happened? Oh, this one tripped everyone up. I'm so sorry. Looking good. All right, it's going to decrease its pressure, right? When I blew on top of the paper, it decreased the pressure, so that's why the paper was able to go up. There was no longer as much force, right? We saw this. Sorry, I'm going to skip this one, but we saw this, guys, right? All right, looking good. Sorry, I'm moving on. Got to go fast. Let's go, let's go, let's go, let's go. Sorry, I want to make sure I get all your results, guys. It's all good. You get your extra credit. That's what matters. All right, loving it, Grant. You were in the lead the entire time. That's awesome. All right, guys. So here's your last word. Thanks so much. I will see you guys later. Have a wonderful day. Thanks for playing with me. Bye, everyone. Yes, Emilio. Hold on. Here you go. Bye, everyone. Have a great day. All right, make sure you guys log off. Make sure you guys log off. I do need to go to my next class. No worries. Yes, next time. Unit 5. You guys got this.